So it's coming to modes, only two modes. One is local mode, another one is HDFS mode, third one is embedded mode. That is separate thing. There we are going to develop the user defined function concept. So coming to execution, one is shell mode, another one is script mode. So now I am in the terminal. Now I am going to interact with the shell. As I said, there are two modes. One is local mode, another one is HDFS mode. So let's see a couple of commands using some of the commands using local mode and some of the commands using HDFS mode in the using two flavors. One is script mode, another one is grunt shell mode, grunt shell flavor. So the syntax, as I said, syntax is same thing. This one in the syntax is, so coming to flavors, first thing is we'll see some of the commands using grunt shell mode. So in the grunt shell mode, again two modes available. We can interact with the shell. One is local mode, another one is HDFS mode. Let's see some of the commands using local mode and then some of the commands using script HDFS mode. And then again in the script mode also see some of the commands using local mode and some of using HDFS mode. So this is the way of interacting with the shell. Syntax is like this way. So if it is local, pig -x local. If it is HDFS, pig and then enter. If it is, you are trying to execute the script kind of environment, script kind of files. So this is the way of interaction. Pig -x local and then script name if it is local mode. If it is HDFS mode, pig and then script name. So what is the difference here in the local mode? So input and output paths should be pointing to the LFS directory, but here input and output paths are pointing to the HDFS layouts. So let's see that one. So now I am entering into the shell pig -x local. So this is just grunt shell. So there is no script mode. If it is script mode, here we can use script mode in the script kind of execution in the local mode. So simple. I am first I am trying to see some of the commands using just local mode of grunt shell. Now this syntax takes me into the grunt shell. So that is the default shell for pig execution. So now I am opening another terminal. As it is pig -x local means input and output path should be pointing to the local file system. There is no interaction of the HDFS. So let's see that one. So again I have opened another terminal. cd pig, right? Nothing available. Now here I am creating one file and then I am trying to load that file into the pig variables and then I am trying to process those files using the functions available or actions available. What are the actions I have written on the screen on the notepad earlier just before. So now I am creating one employee file, nano emp.txt. So I am entering employee ID. So delimiter is pipe symbol, employee name ename 1, employee salary 1000. So like that way, employee ID 101, employee name ename 2, employee salary 2000. So employee ID 102, employee name ename 3, employee salary 3000. So let's take employee name 103, ename 4, some 4000, employee name 104, employee name 5, some 5000. Like this way I have created 5 records. Control X, Y. If you see employee.txt, so this is the data available. Now I'm again back to this pig shell. I am trying to load this file into the one of the pig variable. In pig, everything we can So these are all the 5 records I have entered into this file. Now what I am trying to do is I am going back to this terminal pig shell, and then I am trying to load this file into the one of the pig variable, and then I am trying to process this data. How I am going to load this data into the pig variables. Now pig Latin is a language, so here everything, the internal data which are going to be stored in the pig is in the byte array format, but the variables we are representing, we don't need to mention any data types, like kind of thing. So here we can simply take any of the variable name a, and then using the functions or actions I just explained you, we can load this into this file into this variable. So using load command. Load is one of our first command action, or we can call it as the action or command, whatever it may be. This is the load. So let's see all the actions or transformations one by one using pig. So this is the load, and then here I need to specify file name. So file, where exactly I need to point? I need to point to the local file system directory. So where exactly my file was available? In this path. This is the file name, right? Here, and one more thing is, I came to this directory and then I entered into the shell, right? So you can load this data couple of ways. Either you can completely provide the absolute path like this way. Paste /emp.txt, or you can simply, though I have entered into the pig shell by coming to this path, so you can simply give the file name itself. So either of the thing is fine, there is no issues. So either you can use the complete absolute path, or you can use the simple file name. Why? Because I have entered into the pig shell by coming to this path only. So if you are trying to load the data from some other directory, you simply provide the absolute path. But from the path, from whenever the path you are entering into whichever the path you have entered into the shell, so from that shell, if the file is available, you no need to provide the complete absolute path. Even though if you are providing, that is not an issue, everything is fine. So here I am simply using load file name using BigStorage. BigStorage is the default function available with respect to the Apache Pig. So its usage is to load the delimited separated file, P capital letter, S capital letter, and then here in the single quote we can mention the delimiter of each and every field using BigStorage. And then BigStorage usage is a function available in the pig. Its usage is to load the delimiter separated files. So whenever you press enter, right, it simply loads the data into the variable A. Now if you try to generate generate the data, couple of variables into couple of columns into, so here delimited separated means my file is like this way. This is employee ID, this is employee name, this is employee salary. So like this way, delimiter I have used was pipe symbol. So here while loading also I have used the delimiter. Now how the data is going to be, data was stored in this variable A in the form of internally pig stores the data by keeping the sum of the internal delimiters called by placing the sum of the internal columns, that is in each variable, in the variable A internally it stores the data in the form of $0, $1 and then $2, 0, 1, 2. $0 represents entire this column. Why? Because we have separated the data with the sum of the delimiter, right? $1 represents entire delimiter. So $2 the entire this employee salary column. Say for example in some other case the delimiter was mismatched. Assume, say like this way. I have added like this way, and then I have entered one more record. Here I have used hash as my delimiter. Control X, Y, right? So now again I need to load the data, right? So in this case, what happened, $0 find for the delimiter to terminate this data. So what's the delimiter here? Pipe symbol. So up to here, it has been stored into $1, $0. Whenever the delimiter comes up, so it separates the data and stores internally into the $1. That is the next delimiter data, right? So variable A stores internally in the form of system defined column names, that is $0, $1, $2. So whatever the delimiter comes up, so whatever the delimiter data we have in the entire file name, so up to that it divides the data and then it stores internally in the form of $0, $1, $2, and so on until the delimiter whatever the delimiter available until end of the record. So like this way. So if I try to see only $0 data, this is the way. You need to take another variable for each is another action. So it's what it will do. It does is it simply iterates through the values which were there in the variable A. For each A, generate $0. So generate $0 means generate is also another big action. So what it will do, so it simply iterate through the values which were there in the variable A and then generating $0 value to the variable B. So if you press enter, so variable B contains only employee first delimiter data, so separated data. Now whenever you try to store this data or to represent, so if you want to see what was the data available in this variable B or variable A, so what are all the commands available in the pig? There are a couple of commands available or actions available. One is dump, another one is store. Dump command represents the data in the shell itself. It simply, if you use dump command, it simply display the results in the screen itself. If you use the store command, so we need to specify separate path. We need to specify some separate path to store this contents of this variable. So here, to store this data, we need to specify LFS path. Why? Because we have entered into the shell as a LFS. So we have entered into the shell pig shell as a local mode, right? So that's why we need to point to the LFS directories to store this data using store command. Let's see both the things. So if I want to see what are all the contents available, what are all the things available in the variable B, using dump command, I can see that one, dump B, and then press enter. Now map reduce jobs are getting triggered internally by the framework. So we no need to write anything. So internally framework will call the map reduce jobs, and then those will reads the data, process the data, launch each and mapper and reducer phase, and then process the data. This is the things available. Now if you see, my $0 contains this one, 100, 101, 102, 103, 104, and then as I told you, it will read $0 reads until the first delimiters happen. So now in this case, my first delimiter was here, it happened, right? So like that way. If this is also with some other delimiter, now this entire line will be part of the $0. So that is the internal representation of the data pig represents. So here the data is with some stored in the brackets, right? This is called as tuple. So we are calling this as a tuple data. This is one tuple data, right? This is dump command. Likewise, if you want to store this data into the one of the output path, you can use this store command, store B into output path. We need to specify output path. So I am storing in this path, paste slash pick out. Like that way I am storing. So whenever you use store or dump commands, map reduce jobs are getting triggered, and then process the data. It's define the some plan and then process the data, stores the data on top of the, or store or display the data, right? So it is showing some information saying that input successfully read from this particular path, right? Output successfully stored in this particular path. So the informative, it provides the information as well. If you see pig out, the directory has been created. If you go into that particular path, if you see, sorry, yeah, so here part_m file is there, right? If you see this file cat, right, my data was available. So these are all the two commands, core commands available to display or to store the data with respect to the pig actions. Right. Now I'm in the same local mode only. My aim is to store this data into the some of the variables itself, system define some of the variables to use in some other operations. So likewise I would like to store this data. So let's take the same variable A. You can reuse the same variable. You can reuse the variables whenever you are coming out of the shell. All the variables has been deleted by the framework itself. The whatever the data or variable representations, everything has been deleted by the framework. So whenever you are in the shell, the variable has a life. Whenever you are coming out of the shell, the data is going to be the data, variable names, and then its memory, everything has going to be deleted. So that's the pig, that's how pig is going to be executed, process our data. So now what I am trying to do is, I am trying to load this data into the variable A with some schema representation. So how I am going to use that, how I am going to define that one, let's see that one. Load the file name emp.txt using BigStorage. So Delimiter as EID and then a semicolon, data type ename char array, pig language data type, right? Char array, and then eSalary. You can use int, small int, big int, like that way. Now press enter. So this is the schema I have, right? Like that way I have stored. Now I would what I would like to represent the data I have represented with some schema related way. Now I am going to apply this filter operation. Filter means I am going to separate the data whose employee salary is equal to some 3000, right? So I am taking another variable B, and then use filter A by eSalary equal to some 3000. So filter operation, filter command, what is the uses of filter command? The main uses of filter command is to filter the data matching the condition, by matching the condition. So it simply match the results, match the data, whatever the data, it match to the condition. So it simply separates the filter the data into the another variable. So that's it. So now B contains the records whose employee salary is equal to exactly 3000. Now I am trying to dump this data, dump variable B. Or if you want to store, you can store in the one of the output path as well. Now whenever you are using MapReduce jobs are getting triggered and then data is getting processed like this way. Right. So now I got one tuple whose salary exactly matched with those condition. That is the usage of the filter operation. Right. So filter operation usage is basically to filter the data matching the condition simply. So that is filter usage, filter operation. Now our next command is, let's see command by command, one by one command. So dump, store we have seen, generate we have seen. Now describe. Right. So describe is used to describe the how the internal storage of the data. If you describe B, so it will display the how the schema has been. If you describe A is also with some schema, right? So like that way, if any schema is associated with a particular variable, if we are trying to describe, so it will display the how the schema has been defined for this particular variable. Now likewise, describe, we have a command called illustrate. Right, illustrate. So if you use illustrate, it will display the internal storage of the variable here. So whenever you use illustrate the particular variable, it shows how the data representation, how the data has been stored internally. So variable A internally stored with the schema in this format. So the internal representation format is byte array, always byte array. The data is getting stored always internally with byte array. Right. So we have seen describe, split. Now let's see some of the order by examples. Now let's see some of the order by examples. Yeah. Now I am trying to load the data to the same variable. Now let's see. Let's take some more data. cd dot cat nano emp.txt, and then add some data out of it. So some data into it, add some few more records into it. So now what I am trying to do is 106, ename 7, salary is some 1500, 107, ename 8, salary is 2500, 108, ename 9, salary is 3500. Like this way I have entered some data, some more records. Now I am trying to load this data into the variable A. Right, I have loaded this data into the variable A, and then now I would like to order the data using employee salary. So I am taking another variable order data equal to order A by E salary. If you try to dump this order data is my variable name. if you try to dump this order data, so you can see employee salary should be in some sorted order. Right. If you see here, when I enter the data into this file, if you dump A, can come to know the differences. So whenever I enter the data into the variable A, so the data is employee salary was not in some sorted order. Now I made the data in sorted order using order by action in the pig. So if you see here, my data should be some employee salary was not in some sorted order. So here 1500, 2500, like this way. If you see the data which after sorting, so it should be with some sorted order, 2000, 2500, like that. That is the uses of order by variable or action in the Apache pig. So now we have seen order by as well as filter, right? Order by. Now let's see some of the actions or some of the commands using HDFS mode. So let's come out of this shell. How you can come out? Control C to come out of this shell. As and when you are come out of the shell means all the variables whatever you have defined, those are deleted from the memory, right? So now let's enter into the HDFS mode. How I am going to enter into the HDFS mode? Pig and then enter, right? The syntax is like this way, pig and enter, right? The same shell. If you see here, the way of enter, earlier we used to enter into the pig shell using pig -x local. Now I have entered using the pig and then enter. So this is HDFS mode. So in this mode, the input should be part of HDFS directory and also output also should be part of HDFS directory, right? So if you see here, let's try to execute some of the commands using this path as well. Right. Let's take the same file into the HDFS directory. So emp.txt. How I am going to put this file into the HDFS directory? Hadoop fs minus put the file name into the HDFS layout, right? HDFS 9/pig. So this is the path and then file name. Whenever you are trying to create the file at the very first time into the particular directory, you need to enter the file name as well. After creating this directory, you are trying to put another file, you don't need to give the file name. Whatever the file name in the source, the same file name is going to be copied into the destination as well. We don't need to give the file name from next onwards. But at first time, you need to specify the directory structure as well as the followed by file name. So whenever in the destination itself, you can use some new file name as well, right? Right. So now I am pressing enter. Let's see whether data is going to be copied into the HDFS directory or not. Hadoop fs -ls /HDFS 9/pig/. Right. My file was copied into this particular path. Now I have entered the shell as a HDFS. Now let's see the next set of commands. So what is my next set of commands? We have seen up to order by. Now let's see some of the group by commands. Right? Yeah. Let's see some of the group by commands. For that, we need to load the data into the one of the variable, right? Let's take the variable A. If you try to dump variable A, nothing available. Why? Because we did not load the data. Unable to find an operator of alias A. Because whenever we are coming out of the shell, whatever the as I said, so whatever the variables which has been created in the memory, those are all deleted from the memory itself. The data, contents, everything, references, everything has been deleted from the memory itself. So those variables are not at all available once we are coming out of the shell means. So whenever you are entering into the shell, we need to create the variables again, and then we need to apply the actions. So load, using load command only, we are going to load the data into the variable A, load operation, load action only. So here path, so this path should be HDFS path, right? So here we need to specify absolute path, HDFS path. So where exactly I have copied this data? So this is the path I have copied my file. Now copy and then paste it. Copy and then paste it, right? Load using BigStorage Delimiter as EID, integer, ename, char, array, comma, eSalary, integer. Like this way, you need to enter and then press enter. You need to enter the data, after that press enter button. Now I have the data loaded into the variable A from the HDFS layouts. Now I am trying to perform some group by operation. So because there is no duplicate data available, right? So it should be individual. Now let's try to add some of the duplicate columns, and then let's see how group by command is going to be helpful. So nano emp.txt, how we are going to edit this data? Like this way. Again I am entering ename 10, some 10,000. So 101, ename 11, some 11,000. 102, ename 12, some 12,000. Control X, Y, enter. So now, first of all, whenever you try to edit the data, it is not possible in the HDFS layout. So we need to make the changes in the LFS and then try to move the file into the HDFS directory. Now the file is already existed. If the file is already existing means it throw an error, right? So first of all, we need to remove that file, Hadoop fs minus rmr, this path, entire path we need to give. Right, deleted. Now let's try to copy the data into the same path, right? Now let's try to load the data again. Now the data is with some duplicate values. Now I am taking variable some other variable B, and then I would like to apply some group by operation, right? So group, so how we are going to apply group? A by some employee ID, right? If you are dumping the data to display, it will display in the shell itself. If you are trying to store, you need to provide the HDFS path for that one. Right. So first I just dump the result After that, I am going to store the result into the HDFS layouts as well. So whenever you are use the store command, here you need to provide the HDFS path to store our data. Yeah, here MapReduce is getting triggered, and then the data is getting grouped. So this is my group. So these are all the related values. So always group by class, group by action produce nested output. This is this is entire thing is one tuple. The things which are in normal braces, the things which are in curly braces means this is a bag. Bag is a collection of tuples. These two are the tuples in this collection. So this is with group by 100. So 101, 102. This is the group by. So always group by class produce the nested results. That is the default thing. So this is the group by data representation. So whenever you are seeing the data between these braces, we can call it as a tuple. Whenever you can see data between these curly braces, the inside data we can call as this data we are calling as a bag. Bag is nothing but collection of tuples. So this is one tuple, this is another tuple. Those are part of this group. So like that way the data is representing. So bag, collection, these are all the complex data types available in the pig. So if you want to use that, you have to use those functions using the some of the with respect to some of the existing functionality. So that is group by class about it produces the nested result. That's it. So next thing is join operation. So let's see how the data is going to. For joining, we need two tables. For join operation, we require two sets of data, right? Right. So let's take the department data as well. Let's create the department data dept.txt in the LFS environment. Here department ID is 10101 and then employee ID 100. Department name IT. Department location Hyderabad. So next department ID 10102, employee ID 101, some HR department, in the location Bangalore. So department ID 10103, so employee ID 102, it belongs to some finance, some BPO department related in Mumbai, like 10104. Employee ID is again 103, belongs to IT department in Pune. So 10105 department ID. So employee ID is 104. It belongs to HR department in Chennai. Right. So likewise, I have some department data as well. Control X, Y, enter. Right. So now I am trying to keep this data into the HDFS layouts first. So how I am going to do that one? Hadoop fs minus put department data into, so what is the file name we have used earlier? HDFS 9, right? So we can use the same path. Here we no need to provide the file name, department txt. So why? Because directory has been already created in the earlier case, so that the file is going to be copied into the particular directory simply using -put command. Right. So let's see that Hadoop fs minus ls slash HDFS 9 slash pig, enter. So if you see here, there are a couple of files available. One is with employee data, another with department data, right? So let's try to load this data into the shell again. So earlier I have loaded the data, into variable A, right? Now I am trying to load the department data into the variable B. Again, let's load again. Variable A contains this employee data. Now try to load the employee data B. Yeah. So this contains employee data, and then B, variable B contains load /HDFS 9/pig/dept.txt using BigStorage as DID, department ID, integer, comma, EID, it is integer, comma, D name, department name, char array, comma, D location, department location, char array, right? Like this way, we have entered couple of variables. We have entered the data into the two variables. One is with variable A, pig variable, another variable is variable B, that is variable B. Now what I am trying to do, I am trying to apply join action using pig. How we are going to do that one? So let's take one variable name, join data, equal to, so join A by EID, comma, B by EID, right? If we try to dump the data, join data, so now MapReduce is getting triggered and then joins the matching records. The join means whenever you use just join, so that is, that is the inner join. So whatever the matching employee IDs in the both the tables will be formed as the result set and going to be displayed in the pig shell. Yes, MapReduce is getting triggered. Right. So here the data is getting generated like, so 100, here is 100. So this is, employee table data, this is department table data. So 100 again from employee table data, and then same data from the same row from the department data. The matching is, inner join. So 101, 102, 103, 104, like that way, inner join. So if you want to perform some right join or left join, you can use like this way. So L join, left join one of the operator I am taking. So join, A by EID left, comma, B by EID. If we try to store L join into some of the HDFS location, right? So what is the location? Pig out. Whenever you are use store, so the join data is going to be stored into the one of the output path, part R or part M file. Likewise, you can use right join as well. Yeah, here map reduce is getting triggered again. The data is going to be copied. Right. It displays the message saying that successfully read records from the output path, input paths, and then successfully stored the record into the output path. Some counters as well, how many records has been written, read. So what are all the information, everything. So let's see this data, Hadoop fs minus ls slash HDFS 9 slash pig out, right? So that is the path we have stored our variable data. So here part R file has been generated. If you try to read this data, copy Hadoop fs minus cat so left join, left side all the data, right side matching conditions, right? So this is the left join. If you are using right join means the same thing. So R join A by EAD, instead of left use right, B by EAD. If you try to dump R join, if you see the result as a some right join, right side matching condition, left side null, like that way. If you are using full join, you can use full join as well. Full instead of left right, you can use full. So that is what the join operation in the Apache Pig. Now let's try to load the data once again. So this is my employee data. I am loading into the employee data. I am loading into the variable A, and then this is my department data. I am loading into the variable B, right? Now let's try to use the union operator, union A comma B, and then try to dump this data. So dump union data. Now whenever you are using this one, map reduce jobs are getting triggered. It's simply, just union is nothing but just result set becomes the combination of two data sets, two tables or two data sets, like this way. So this is the usage of the union.